All right, we're going to start by starting with the bare board, and we're going to have a 1K resistor, a 10K resistor, a 2.2K resistor, the diode, the 100 PF cap, and the 2.2 PF cap, which is labeled, you can't see it, can't focus, 222, and the other one's 100 PF. It's got a little black dot on top. Your barrel connector, the coil, the trimmer pot, the 4.7 microfarad 450 volt capacitor, socket for your 555, a 555, your NPN transistor, and the MOSFET. These are the parts that you're going to need initially to get the power supply going, and it's actually the trickiest part. And it's not tricky, it's just that you build this first, and then using your meter, you adjust the trimmer pot till you get to 180 volts, and you're done. And then you can continue to just build the rest of the circuit out. So it'll look, you know, more like this, with all the parts and components on it. I'm going to send you a better schematic than the one that is in the box. But this is step one. So I'm going to start on this MOSFET. Isn't 740. It's going to go here. There you go. The 4.7 cap, the 100 UH coil, the 2.2 or 2N2. I should have done this first. Ceramic cap. A little itty bitty 100 picofarad. It attaches to the MOSFET right there. The 2200 ohm resistor, which is red, red, black, brown, brown. The 220K, hold on a second, I gotta get out my tray. I didn't pull it out. Just to pause real quick. I had to go hunt for the 220K. That's red, red, yellow, gold. Okay, when you put the trimmer pot in, have the I guess you call it the trimmer screw, pointing east, I guess, this way. See what I mean? Okay. Your diode. Now, when you do the diode, to bend the wires so that the part of the diode that is the cathode, that's marked with a gray band, has the that wire, I should say, do it in such a way, there you go, that the cathode is buried and there's not a lot of wire sticking out, and the reason why is because that's it'll shock you pretty good. I mean, it's not going to do anything to you. It's just, it's a good zap. And so if somebody's holding it and they start touching around and stuff like that, if that part was exposed, or if they touch it from the bottom, they're going to get a zap. It's not going to kill you, but it's more like one of those little shockers that you made in high school. The NPN goes in. Come on, NPN, get in there, all right. the 555 socket. We'll put the 5 in last, of course, just before we test. Okay. The 1K, which is brown, black, red, which is basically, so the brown is a, get these confused. Anyway, the 10K is brown, black, orange. That is correct, and the 1K is brown, black, red, which would be a 1, a 0, and 2 zeros after that. That's the 1K going in here. The 10K here. When we're done soldering this together, oh, I forgot an important part. What you want to do, take your razor knife, and you see this perforated edge, a perforated line right here. You want to separate. These two boards from each other. So just run a little razor edge on. Just score it a little. You don't really have to hit it that hard. And because it's perforated, come apart just like that. See, and this, put it away for later. You're going to want to solder the barrel connector on as well, so that we can apply power. When we've done that, we're going to apply power, and then we're going to measure between ground and this high voltage test point, which is right here, which I put in there. So we're and then I have a ground right here. So just between any ground and this high voltage test point, and then we're going to adjust the trimmer till we get to 180 volts, and that will be basically stage 1 of the clock done. And I'll talk about the rest of it. The rest of it is just parts falling into places. So hold on a second while I solder this all together now. Okay, it's all soldered together. I'm just going to do some snip ups, and then we'll check to make sure the power supply is working. Try not to put an eye out while I'm snipping these wires here. Let's see. Gotta get better glasses. Now the MOSFET, what I'll often do is align the hole like so, and then I will put a nut in there, or it actually isn't that necessary to put a nut in there as a heat sink, but you could just put a little solder down on this side and some solder on top, and I'll do that later. Oh hell, I'll do it right now. With the intention of just basically giving it more surface area, because I've got this pad to dispense the heat on both sides of the both sides here, and it just needs to be soldered into place. And so between the solder, that pad, and the heat sink that's already on there, there we go. It's all one part now. So you can see. I don't know why you can see that, but that's enough heat sink right there. So I should be able to put the 555 in, and it should, given the circuitry around it, oscillate and operate the trigger the MOSFET there, and which is then going to generate the high voltage, which we are going to adjust. I screwed that up. Hang on. Hold on just a second while I straighten these pins out. Okay, that embarrassing part is over. It's all fixed up. So now, set this to 200 volts. Find a 12 volt power supply in this bin of stuff. Yeah, this will do. Plug her in. Okay. I have that ground there on purpose. I have this high voltage here on purpose. It's at 37 volts. Now we adjust the trimmer. I don't know if you can see that. And we want to get it to 180 is the voltage I like for the tubes. 59, 61, come on. Okay, 80, 90, 100, 122. The tubes will light anywhere between 165 and like 200 and some volts. It's very low amperes, by the way, and it's just neon. 191. So I'd like to run them just a little below the rated for longevity, just below their rated voltage. 177, 178. So we can adjust that later if we need to. So come on, 180. I'll take that. All right. So the high voltage circuit is done. Then what we're going to do next is same thing that I've already done on this board. No soldering's been done yet, but just populate all the resistors that go in there, all the other components that go. I can talk about why we're using optocouplers, which aren't on the board right now. The optocouplers are, if you're not familiar with them, you may want to read up on them, but they're separating the 5 volt part of the board from the 180 volt part of the board, and because this other LM7805 here, so we got 12 volts coming in, and you got the LM7805 is creating 5 volts, and that's what drives all the 5 volt side of the board, and then you got the MOSFET and this other circuitry that's creating the 180, and that's going up to the tubes, but it's being gated right here. So this is basically the bridge point between the 5 volt and the 180, because what's happening is they're isolated, but the 5 volts are being triggered by the 5 volts are being triggered by the pins on the microcontroller, saying, you know, turn on, turn off, turn on, turn off, and in its isolated way, it's, you know, turning on and turning off the 180 volts. So that's a more unique way than I'm doing. I said more unique. This is a different way than I'm doing it than a lot of other people who just use high voltage transistors for their Nixie clocks. I prefer it this way. Anyway, there you have it, and that's stage 1 out of the way.